2.4, and this is infinite limits. 2.4, infinite limits. Yeah, so before we'll talk about infinite limits, we've seen a couple of those, maybe one. Let me remind you the idea, what the idea of the limit is. So basically, a limit is a value of a function when x's are approaching a certain number. So let me give you an example. Right, so if I take, maybe let's just take something simple. So y equals x squared. Okay, so let's calculate the limit with x approaching -3 of that function, right? So x squared. Right, so in this case, let me maybe draw a picture first. Let's do it graphically first, right? Because we can, it's pretty easy. Okay. So this is just a regular parabola. 2 we have 4, or 2 we have 4. I should have, anyway, doesn't matter. Should have picked a different number. Maybe, what can we do here? Yeah, let's change it. I'm changing it because, right, the limit will be 9, right? So we won't be able to see the limit. So let's put -1 here instead of -3. Okay, so -1. So the -1 is right there. -1. And this is -2. +1. And this is 4. This is 2. Okay, so yeah, so we can, you guys see what the limit is, right? So if I'm getting closer with my x's to, let me get a laser. All right, so I'm getting closer and closer to that 1, or -1, sorry, from the left. And then I get closer and closer to that -1 from the right. Right, so the numbers I'm plugging into the function are like a -1.01, or maybe -0.99, etc. Right, so if I'm getting closer with my x's to that -1, you guys see what's happening, right? So my y values, the value of the function or the limit, right, is going to be -1. Okay, so we've seen it graphically, and just algebraically you would take this -1 and plug it into the function. Right, so let's do that. So I have limit with x approaching -1, and then maybe I'm just gonna plug in that, substitute that -1. Right, so -1 squared equals 1. Okay, so that's pretty simple. The problem is that sometimes the value of the function, or the function is undefined for the number. So let's take a different example that I showed you last time. So maybe let's call it example 1, example 2. All right, so let's take a limit of that sine of x over x. All right, so with x approaching 0. All right, so again, graph. All right, so this is 1. There's an open circle around it. Change color. And then the graph of the function is something like this, right? Those amplitudes are getting smaller and smaller to the left and to the right. So you see what's happening, right? So I'm approaching 0. right? My axis from the right, from the left. And even though the value of the function at 0, right? So this is origin 0, 0. The value of the function doesn't exist, and because if I plug in that 0 into the denominator and numerator, I get 0 over 0, so indeterminate form. But the limit exists, right? Because we're not concerned about what's happening at 0, we're concerned about what's happening close to 0, right? So I'm plugging in numbers, like 0 point on the right, I don't know, 0.01, right? And on the left, negative 0. Okay, so numbers on the right, are close to, so it'd be 0.01, right? And numbers on the left would be similar, right? So negative 0.01. Anyway, so if I do that, right, I'm simply getting 1, right? So that limit is 1. Okay, so there are two cases where limit existed, and I think I showed you an example where the limit didn't exist. So example 2, I think it was something like it was, again, I need to move it up. I forgot. Let me get this here, if I can. Maybe I can't. I don't know. The limit was, I think, with x approaching 0, and that was absolute value of x over x. Okay, so the limit here didn't exist. Because if you start plugging numbers, let me double check if that was x approaching 0, right? So let me rewrite it here. So limit with x approaching 0, and the function was absolute value of x over x. Okay, so if we graph it from the left, it will look like this. So that'll be 1. And you can plug in a couple values, right, close to 0 and see what's happening. And then on the left is negative 1. Okay, so you see that the limit that when I'm approaching that 0 from the right, and the limit is 1. When I'm approaching 0 from the left, the limit is negative 1, so the limit doesn't exist. Okay, because the limit from the left and right, and I'm approaching different numbers from when I'm going towards that 0, and from the left and from the right, I'm approaching a different number, right, for y. Okay, so that was so I hope you understand the idea of the limit. So now let's talk about the infinite limits. So in example 1, again, and we need to find the limit of something like this. So f of x equals 3 over x minus 2, and where x approaches 2. Okay, so if we want to calculate the limit, we can't really plug in that x, right, because I'm getting 0 in the denominator. So I have limit with x approaching 2. Okay, so we have 3 over x minus 2. All right, so let's look at the graph of that function. All right, so this is a hyperbola where right, so regular parent function would be 1 over x or 3 over x, but now we have this minus 2, right, in the denominator, so that will shift the graph to the right by 2. Right, and then we have the regular shape of that hyperbola. Okay, so here's the right branch, here is the left branch. Okay, so I'm approaching 2 from the left and right. So if I look at my function, look at the value of the function when I'm approaching 2, so this is 2 right there. Let's make it right. So you see what's happening, right? So if I'm approaching the 2 from the right, we could make that arrow right over here. We could think about it here. So if I'm approaching 2 from the right, the value of the function, right, goes up. So it goes to infinity. So I'm going to write it like this. So limit with x approaching 2, right? The little plus means from the right. And then, let me just write the function f of x. All right, so we see that if that is happening, if I'm approaching that, I don't know if you guys probably can hear that baby crying. Well, it's not a baby, it's a little boy. Anyway, my neighbors. So I'm approaching the 2 from the right, right? So the function goes, we see what's happening, right? The function goes just to infinity, positive infinity, right? And then we can think about it. I'm not sure. Now it's somehow different, right? When I'm trying to move the page, it just goes to the next page. Anyway, I'll deal with it. So when I have limit, and now I'm approaching 2 from the left. Alright, so over here. 2, not 0. Okay, so I'm getting towards that 2 from the left. So I indicated it by that little minus there. Well, then you see what's happening, right? The value of the function just goes down, right, to negative infinity. This is supposed to be infinity, negative infinity. Yeah, so it's similar to this example here, right? When I approach my my number c, right, 0 in this case, from the right, and the value is 1. Approach from the left, the value is negative 1. So I get from left and right, I get 2 different numbers, right? Infinities are not really numbers, but we could pretend they are. So we're going to say in this case, and also in the case where if this was, I'm going to give you an example in a moment. If this was also positive, right, like this, that wouldn't mean that there is a limit, right? Because limit just implies some kind of number, right? A limit, but infinite is just infinity doesn't have a limit, right? Anyway, so this was minus. So sometimes we would write, right, the limit of something, of some function when x approaches 2 equals infinity, but that doesn't mean that limit exists, and it just means the end behavior is infinity. So let's just write limit doesn't exist. Doesn't not exist. All right, so that was that first example. Let me give you an example where both left and right limits go towards the same kind of idea, concept, right? Infinity. Anyway, let me give you this example. So example 2, and the function looks like this. So I have 1 divided by x minus 1. squared, and yeah, where x approaches 1. Okay, so in the previous example, what we did, we graphed it, right? But we can also solve it numerically. Okay, so yeah, let's think about it. So let's do, right? So let me write that limit first. So limit x approaching 1. So I have 1 over x minus 1 squared. Okay, so I'm approaching 1, right? So what I'm doing, right? I'm getting closer. Let's look at that limit from the right. So let's just put the plus there, right? So to indicate that we're going towards that limit from the right. And yeah, what we'll do, we'll just solve it numerically. So solving numerically. Right, so we've done it before, right? We were plugging in or substituting numbers in for x. They were close to, right? Closer and closer to some number. 2, right, was our first example. In this case, I'm going towards 1 from the right, right? So closer and closer to 1 from the right. All right, so yeah, so let's start with maybe number 1.5. So for x, so for x equals 1.5. All right, so I'm doing f of 1.5, and we'll try to figure out where my values, right, where the value of the function goes. So I'm taking 1 over, here I have 1.5. It's supposed to be minus 1, right? Minus 1. Okay, so let's figure out what that is. You put just use the calculator. So I have, let's see. So 1.5 minus 1. Oh, there's a square missing. So I need the square. So 1.5 minus 1, so that's 0.5. Now I'm squaring it, so it's going to be 0.25. So I'm dividing 1. Let me just double check it. So 0.5 squared. Yeah. So now I need to do a reciprocal of that. So 1 over 0.25 gives me 4. Right, so that was pretty close to 1, but not really. Right, so let's do f 1.1. Okay, so we have 1, and in the denominator I have 1.1 minus 1 squared. Okay, so I have 0.1 squared. Let me do it here on the calculator. So 0.1 squared, and now reciprocal of that. Okay, so that's 100. So I hope you guys know already what's happening. All right, so let's do f of something. Let's do one more, right? Something like really close to 1. Okay, so maybe I won't do that. I won't write that. I'm just gonna give you the answer. Okay, so I have we have points and 3 zeros, 2, 3, and then 1. Okay, and I'm squaring it, and then I'm taking a reciprocal of that. Okay, so we have 100 million. All right, so I hope you see what's happening. 2, 3, 1, 2, 3. Right, so from this we see that when x approaches 1 from the right, the value of the function or the limit is infinity. And yeah, the same thing is happening when I start approaching 1 from the other side. So let's do just a couple, maybe 1. Let's do 1. So let's do 4x. Let's do 0.99. 99. Right, so I'm approaching 1 from the left now, right? From the left, because on the left, right, the numbers are close to 1 are 0.9 and then bunch of 9s, right? Anyway. Alright, so I'm doing f of that 0.99. Okay, so let me see what we get. So I have in the denominator I have negative 100, but I'm squaring it, right? So it doesn't matter. 100, so that's gonna be point and then 1 0 and 1, and that is squared, and then reciprocal, so I get 10,000. Okay, so you see that if I'm approaching the number 1 from the left, I'm also, right, getting positive big numbers. Okay, yeah, so let me write kind of that. How would I like you guys to write the answer? Okay, so we'll write something like so. Let me write that. So I had limit with x approaching 1, right, of that function. So that was just f of x, and we get positive infinity, right? So it's the same kind of value, right? The same thing. Whether I go towards that 1 from the left or from the right, it doesn't matter, right? I get that positive infinity because, well, it's because I have the square here, right? That's what, right? What is my function here, right? I have a square, so it doesn't matter, right? Whether I have a negative, I get a negative number here or positive number, it's gonna be positive because I'm squaring it. Okay, so we have that infinity. So we could write like a little paragraph, maybe not paragraph. So Sx is approaching 1. All right, so when that happens, let me write that function. So let me hold on. That's not, it's supposed to be infinity, it's supposed to be 1. All right, so I have that function. So I have 1 over x minus 1 squared. Okay, so as x is approaching 1, right, the value of this, right, is getting smaller and smaller. And also, well, the whole, right, this, let's just think about that x minus 1 squared, right? So that the expression x minus 1 squared is getting smaller and smaller. It's right, therefore. We could write, let's just write 1 over x minus 1 squared is getting bigger and bigger. Oh, maybe let's put maybe greater and greater. Bigger is just a little weird. So greater and greater. So we can write, so it approaches infinity. Okay. So quickly at the graph. Let's look at. Alright, so graph. So here's our asymptote at 1. It's supposed to be all dashed line. And then the graph will be here. Alright, so it's just a 1 over x squared, but it's shifted to the right by 1. Alright, so that's the graph of the function.